If you're going to be software developer, keep that in mind. So, system admin, DevOps, they don't like it. These are facts, and these are things you might see in the real world. So, when we talk about security of hacks, most hacks or I would say attacks, they attack bugs in your system. They attack flaws in the system. And these systems, strangely enough, are built by developers, and we don't get enough credit for that. Most of the time, we get heat. Heat means that we are taking credit for the software is not working, and we are getting like all the trouble of the world. So this talk is about effects in security. This talk could also be called an effective system to make your code safer. Why do I mean we need more safer code? Safer code means the code that is more resistant, more resilient to attacks. If you have a crappy code, buffer overflow. We see buffer overflow accounts for over 50% of attacks. And strangely enough, it's mostly comes from C, the base, and Java formula. So here I want to talk about effect system. And I'm going to explain what's an effect system and so forth. So on the agenda, I'll explain the problem with correct software, the basics of programming. I'm going to go back to the basics because so often we talk about all these things about programming, object oriented programming, intelligent composition, and so forth. But many of us at some point forget the basics. Basics of programming is so lost in the graphic field. So, problem with software. Let's start with let's take let's say the obvious ones and get rid of the others. Complexity. Most software nowadays, we are no longer in the world that we did in the 90s, where you just put a disk in your machine and it works. Some program will then give you a free plus, folks call, you just take that thing and you run it, and it works like for years. We're no longer in that world. The world has become more complex and it is reflected in the software. And with complexity comes safety. How much safe are your software? Now, here's the trick. I write a program, let's say in Java. I depend on the JVM. The JVM depends on some line on the JVM depends on the C level, and it's written in C. How safe is my JVM? I will go to one talk, was given in 1980, about almost 42 years, by Ken Thompson, why he got his Turing Award. And when you get the Turing Award, it's like the Nobel Prize of computer science. There are two prizes that you don't get Nobel for. One is mathematics, and the other is Turing Award. Mathematics is because I think Nobel's wife had an affair with a mathematician. That's why he said no more mathematicians. And that's the legend. I don't know how true it is. And for Turing, because Turing came way, way after Nobel, and we get the prize for that. I mean, not we, but the genius of our field get the prize for that. And the thing is, when they give you that prize, you give a talk. And when he received his Turing Award, Ken Thompson gave a talk about deflection in truth. This talk is so deep and profound, but not only applies to computer science, it also applies to some of the real life aspects. How much they trust the system, the institution. But when I say system, it's not only your software. How much do you trust the system integrity? And our position says very important, and we know how much this means. And the first problem with software we have nowadays is documentation. When I was a student, that was many moons ago, in the 1990s, late 1990s, there was one lecturer who told us, when do we write documentation? you write documentation before you write the code? I said, yeah, most of it, no. Most of us don't write our documentation after writing the code because we are so fucked up and so tired. We say no documentation. So the answer is we write the documentation during development, which nobody does. We bitch about it, we say where's the documentation, but we ourselves, we don't document. So we are eating our own lunch. And by the way, my language is very loud.
He has a very flowery language.
That's why we love him. So, I'm going back to the basics of programming. And in programming, there are a few things that you have to do. And one of them is types. And types is the simplest answer for types is the name you give to a set of values. Example would be integer, floats, and so forth. You can define your own types through records, structures, in object content you write the class for that, and so forth. Second one is control structures. I will go deep into that in a few minutes. And the third one is when you do programming, you need the toolings, the debuggers, the profilers, the logs, the metrics, trace. If you are going to do software development, these tools, the tooling part will be like part of your tools. That means you're like a plumber, and these are the tools that you have to bring everywhere you go. And software developer, yeah. That's why there are not many software developers who hold. Many of us leave the field a lot longer than we think. What want to manage that? Okay, control structures. I think many of you guys are students here. So, do you know what control structures are? So, control structures are about the flow of your program. So, I'll go through some of the basics of control structures. They are, I mean, most of it must grow up to it, just you may not know the term control structures. Great. Let me sort of, a few, give me 2 minutes now to talk about control structures. Sorry about that. I know I've lost my time. So types, I always say what it is. And what are they useful? Remember earlier on I talked about documentation? Types are a form of documentation. Many of the dynamic language what we have are now having static types incorporated. I was very, very astonished a few weeks ago when I read about the documentation of PHP 8 and I talked with PHP. PHP now has static types. So, so just remember, those were very dynamic language a decade ago, and they were very bad. For those who bring PHP 5 on something, they will know what I'm talking about. So the types of documentation, but there are two types of documentation. The documentation for other developers and yourself, your later self, and the documentation for your runtime or your compilers. Based on those information, the compiler can optimize your code. Based on those types, documentation can be generated. You can go with the API. You can know which parameter you have to pass and what's the type of the parameter. Think about having a function with 5 parameters and you don't know the type. And the guy who wrote it is no longer there for many, many reasons. He may be dead, he may be not in the company, or he just wrote something bad and he just left because he didn't like the money. So now you have a guy gonna dealing with that shit. Literally that shit, and your mouth will be very, very far away. And believe me. And there's one thing about typing. How much typing is enough? How much typing you put in your code? And there are alternatives to static typing, like in a language like Smalltalk. It's very, very sad to see that Smalltalk is not taught in universities or schools. It's one of the most beautiful languages out there developed by Xerox Spark. This is where the double jet was invented. Object-oriented was created by similar in the late 60s or early 70s, but the term object-oriented was invented by Alan Kay at Xerox PARC in a language course. And it's such a beautiful and elegant language that to this day has been copied a lot by Java, by the C#, but we have never been able to equal it. And that language is 20 years older than any of what we're using right now. Okay? So an alternative to static typing would be to use an environment-based development system like Smalltalk. Right? This is beyond the scope of this talk. But I will come back to Smalltalk as a reference. So now I talk about control structures. They define the flow of communication. And you cannot write programs with them. You are already using control flow. You just didn't know the name. An example of a control flow would be in C-based language or PHP-based language or language in the Algol family would be a semicolon. The semicolon is a control flow. It separates statements, separates expressions. So I will give you the basic one, and most of what at O-level must know about it. It's called sequential, radio code one after the other. Selection, that will be your class if and else. Switch case, and those who do Scala or Kotlin will be the point of the match base expression, or now you have pattern matching in the form of selection. You now have pattern matching in Java. That tells you how important this integration actually is. So another one will be iteration. Iteration, when I talk about iteration, most of you think about while loop and for loops. It's much bigger than that. And there's a paper in 2007 called The Essence of the Iterator Pattern, in which it talks about how you can iterate even on data structures and even about effects. I will talk about it a bit later. I'll try to compress my talk as far as I can. So over control structures, and we can say more advanced or whatever other term you want. One will be exceptions. Java has check exceptions. Exception is a form of control structure. And when you deal with exception, you have to deal with your stack trace. Most people don't know what a stack trace is. And some are there to say that it bothers me because they call themselves senior, they don't know what a stack trace is. And I say, how do they get back that senior? Again, this is just bashing in me. So another control structure will be your coroutines. Example of coroutine being used, there's one that came out a few years ago. And even for a few years ago now, it's a long time. We async await. You can see async await happening in almost most programming languages. Java, I mean, for fuck's sake, it's happening. JavaScript, we have fucking JavaScript being used and abused over there. We have generators, Python, which we can yield a value and can continue the processing somewhere else. And you have fibers, stubs, futures. Those are used as a way to have asynchronous programming. Okay, coroutines. This in itself is a kind of work. There are like 4 types of coroutines defined in 2003 by the guys who invented Lua. So they are the expert in coroutine. They are the expert in coroutine, and the guys who are competing with coroutine will be continuation. So PhD students all around the world have been working on continuation, studying continuation, coming up with papers on continuation. These guys, they studied coroutines and they wrote papers about coroutines. So coroutines, you have like 4 of them. You have stackful and stackless. So your async await, as you have found Kotlin and over JavaScript, or stackless. Then you have a stackful coroutine, like in Go. So you have Go developers here, and we use coroutine, they do some show off with their coroutine, like for this stuff. They are stackful. Your generators are symmetric. coding. When you have asymmetric coding. So asymmetric coding is just like an asymmetric game at each store. I create the coding, but I'm not the one who's going to handle it later. It could be somebody, some other coding. So this is one form of cross-code structure. Another structure will resource handling. Resource handling is when you open a file. When you open a file, at some point you have to close the file. And you will be astonished at how many bugs, how many security flaws happen because the connection was open, it was not closed. Which, everyone may have to content information. The other system, I mean, you bashers.
So you have to
So, here's the trick. Most of the bugs, the flaws you found in the world, you find multiple times. You don't find the positive checker. Most of these code have been compiled. Compiler said, oh, what do you mean compile? It was a test checker. And yet when you put button on the check, shit happens. And these things are what creates security. The hackers, black hat, white hat, whatever you want to call that, they read about those codes. They know which library you're using. They know the vulnerabilities of those libraries. And this is where they can attacks. So an example of a bug in the wild. There is one library called the zip library. It's used everywhere in the Linux ecosystem. In the Linux ecosystem, it's used everywhere. It's so prevalent everywhere. It's like the air you breathe. It's like it's there, but you don't see it. Guess what? At some point, I think it was 15 years ago, we found out this bug. And security flaw in the zip library. How many software was corrupted? All of them. But it was a fact checker. It was the test. Millions of users were using them. And yet nobody saw it. Again, it's like a getting great. At some point you will grade, you will decide you will die. So, I'm going to talk about another concept in programming, but let's talk about it's called effects. So I'm going to talk about effects, example effects, and how we represent them in software. One thing you one thing you have to take away from this talk is that knowing about effects will make your program safe. I said safer, I meant safe, not the same. Okay, I will give you some more if you go on the Python algorithm, what is an effect, you might get some more specs. So an effect would be when you run a program, it's anything that can be observed from outside the program. The program opens its socket. You can observe particle next started. You can open a file, you can check which file is open. The program may create a file and put some dead images, but it's also an effect. But it is not inside the program, it's outside. So effects are functional program that do something. I mean, outside of computation. When I say computation, it's what the CPU does. Like adding numbers, changing numbers. Your CPU knows only about registers and changing numbers. When I say outside computation, I mean what it does to your machine. So, and how it affects this environment. So your program may create a big file on this hard drive and make it impractical to use. There used to be a virus or a malware. I would just create files on your machine. And you create lots of them till your machine becomes impractical to use. So this is the visual effects. And effects can outlast your function use and can outlast your program. You can create something, shut down, but the effect it has done on the machine stays. It's like having, so very joking, I might do this, but it's like having an illness. You get rid of the illness, but the scar is still there. So the thing is that there are lots of effects, and I can change the state of your computer program. I'm going to show you some of the effects. Most of them you already know. I'm just shining the light on. Big hiding a lot of cracks. And now I'm just going to shine the light on some effects. I mean, I'm just going to display the most obvious there. So an obvious effect, I just mentioned that I/O, input and output. Your mouse, your keyboard, your screen, those are input and output. I'm just naming the obvious. The printer goes to input and output. Asynchronous is an effect. When is that code executed? You send a piece of code, it's going to change something on the network, have something on the cloud, have something on some server to execute. The code is going to change it there. That's not linear. What asynchronous means, okay, let me explain what synchronous is, and you might know what asynchronous means. Synchronous means to be bound by the God of time. And here I say chronos because chronos are the way for the God of time. But there's a thing about it. It was in the Greek, just like in all civilization, they only knew about linear time, past, present, future. So the God of time only knew about those things. So when we say asynchronous, it means that we're not bound by linear time. You say, okay, open connection to database. You don't know when you're going to get it by connection. So your next statement may not be executed right away. 1 second after, because you don't know. You're not bound by linear time. You might get a database call, you say, okay, fetch me, select from student. The database can execute it, it's start executing and send you back data. But when exactly will you get back data? You don't know. Because so you're not bound by linear time. Another effect would be errors. Another error, and a more specific form of error, would be the absence of data. Absence of data is an effect. When you have state change, data being changed, but you don't know where it's changed. And this might seem so dumb, a state change. You do that all the time. X = X + 1. You violate all the laws of mathematics when you do that. But yet we do that all the time and we don't know what's the Now you might say, yes, but my program works and you have a loop and you just implement the oil. That's good. Do the same state change in an asynchronous environment. Most of you will lose your hair rapidly. Dependence injection is also a thing. And there's the last one which may be less known called code divergence. You call it function. Do you know what this function will run infinitely? By just calling that function, just say, okay, run. You don't know whether it's running infinitely. An infinite loop. Or the condition being put in to make that function run infinitely. You don't know. An example of infinite loop we use between servers. Servers might run like an infinite loop. Or the async await that we use running an infinite loop. We just toss in a queue and then execute them as we go along. So the event loop. So it's a name. So code divergence, we just say it's an effect that says that this code never completes, never finishes. It's called code divergence. And guess what? Most programming languages don't even have a way of telling you what function is in infinite loop. Think about it, and take your time to think about it. You're calling a function, you don't know whether it's infinite loop in it. Okay. So we have mentioned effects. Both were there was much more on this. I'm just giving So, problem is, when you write a program can move and one effect, you have 10 times. Some function may return 2 or 3 effects. Another function returns the same effect but in different order. How do you mix and match? How do you compose effects? And recently, for the last 10 years or so, some languages have been giving some effects in their language. They don't give you a way to write your own effect or to define your own effect. They give you some of the basic. Strangely enough, you already know about this. So I hope some of you have done some JavaScript or some TypeScript. I just hope I've learned some of those languages. I'm not talking about C or Java. Java, we only have only one exception. So maybe try your resources, that means it work on the exception mechanism that we have. So the problem of effects have been there since the days of programming. I mean, it's there. And most languages, the very first of them, were having effects represented as values. You open a file in C, you turn to a null or the actual file head. And you put that in the variable. So you check if it is null, then you press. Or you return to another value, and from this value you can check. PHP also told us about. Either it returns you an array or returns you nothing, or negative 1, and you have to check all these values. So they know about effects, but they cannot represent it in a proper way. And the thing is, effects as values is good, but they did not present it properly. The coding was bad. And the reason why it's bad because most languages were product of the time. C or C++ or any of these languages, they came from a time where hardware was expensive and memory was expensive, CPU was expensive. My first computer was 640 gig, and we thought it was a lot, just like the days. And we left the world was wrong. And we didn't have a hard drive. I had a computer of 512 gig. So we were working on software with very, very tight resources. So those languages did not have the luxury of representing effects like this. But times have changed and the value of effects have started to be imported. And so another way to have effects will be through monads. That's something from functional programming. It's not that complicated. But if you talk about the mathematics of monads and I will call it abstract algebra, category theory, and all that, well, I will burst your head, like in scanners. But it's a movie. But I'm not going to talk about those mathematics. First, I'll just show you on the web pages how it is. Another encoding of effects will be through tags. And the US key on the block will be through effect handlers. So let me show you. So one way you can represent a monad, and this is a language that is not functional. You cannot be more imperative than Rust, but it has some functional construct. And you have this thing called an option type. An option type, strangely enough, if you look at it properly, and you take your time to look at it, it's a monad. In fact, it's even said in the documentation. And you encapsulate an effect in it. So a monad is a way to represent an effect through a data structure. And I do hope any of you who have some computer science know what a data structure is. And there's a reason why I'm saying that because some may not. So, and now with options, we can do none, or you can have some one. And a language like Rust doesn't have none. It's a system programming language without none. There's a reason why Rust has been getting so much love for the last 8-10 years, is because it has very popular in Rust would be state change. Most people who do Rust think that Rust emphasize on immutability, your volume doesn't change. You're going to be so wrong. Rust says you can do state change, but you have to make it explicit where you're going to change the variables. You have to express back through your function that your state change is representative of types. And you need to know that you have had the effect of state change. The reason why Rust has become very loved, and I hope you guys will understand, right? Oh, some language in back failed. Because in the years to come, Rust is going to be back. Microsoft is hiring Rust developers. So this is one way. So a monad is a data structure that encapsulates an effect. But the problem with monads is that they don't compose. So monad doesn't compose. Let me show you that. I noticed that thing and I even chose a picture. This is Haskell, so no need to worry. So a monad won't compose. You have a monad that encapsulates an effect. For example, this effect. The identity effect is just an effect that does nothing. You have an exception effect, you have a reader effect, you have a state effect. And the thing is, those effects piles up. And makes it, and if you want to get the value 8, you have to remove, open the box of state, open the box of read, open the box of exception, then open the box of identity, then get the value. It's like those matroshka dolls. And for those who don't know what a matroshka doll is, it's like this. You know those Russian dolls, the door inside the door, inside the door, inside the door. So this is what you get with monads, and this is why it's a pain. This is why people who do Haskell think of themselves as geniuses because they deal with that thing. They are not geniuses. Yeah? So the other one I'll talk about will be tags. Tags, and I'll give you a language, I'll give you two languages, by the way. One will be called nim. So nim represent effects to something called pragmas, and it's actually the different types of effects we have. So one effect, for example, would be exception effect. Let me go a bit down and show you a more interesting effect. So let me show you. Can you guys see the type IO thing? Or can you guys see that? Yes. So here's the trick. If you have a function and you don't want that function to access the internet, you don't want that function to access an email, you can either allow it or discontinue it. So you can say, I will only accept function that don't have an access to email, an access to the Active Directory. And if you don't have that kind, and your function don't have access to Active Directory, you can call that function. And by the way, this language has nothing to do with function call. This language is a very, very imperative language. It's called NIM from Germany, so maybe you might know. And here's the trick. It also invented, this is something that they invented in NIM and it became popular. You will forbid any function that can access, for example, some form of effect. You will forbid any function. I will not call any function that access the Active Directory, access the web, access some part of the system that you don't want. Think about it. By just looking at this function, you know you cannot access the service. You cannot write to the file. You cannot kill a process. And there is another one, and the newer language. This one is functional, very deep to my heart. And so this is a language called Rock. It's written in C and Rust. So it's very good, very fast. So what it does, it gives you tags and it gives you something called a platform. So you're compiling, for example, for Wasm. Wasm is going to be the next big thing in our file from a C compiler to WASM. Here's the trick. WASM doesn't support file provision. You may write a piece of code but have access to the file, compile it to WASM, also run and test it and so forth. But then with some condition, some files the system trying to read a file, WASM trying to read a file. You're going to get the runtime. And nobody knows why. Why? Because WASM doesn't read file and you compile it against a library that reads file. What does, it gives you a platform, and the platform has set of effects, predefined, and file system reading is not bothered. So it already constrains the effects you can have. Think about it. You can do a piece of code that don't call the file system. That cannot call the database. There's a huge amount of errors and flaws that already discovered. Okay? I'm going to give you another thing that's going to be popular. You can align the patterns over. So another way to view effects will be something called capabilities. Now this is where the other system admin in the house. No? The best I mean, where? So effects, so capabilities is another way of looking at effects. So it's just me, I'm giving this function, instead of saying what function can return you an exception or return you a no value, you say I give ability to that function to be null. It's almost the same thing as an effect, but it's just a different view of it. The view is I give you some capabilities. Now you might say capabilities, when my head is hurting, all these are new concepts. So you need to further away from the world. Capabilities is over 40 years old.
Yeah. Does anyone do Android development? Mobile development, Android? Actually, there you have this concept that you need to describe the capabilities of your mobile app in order to gain the permission to execute certain functionality or to get access to certain resources on the hardware. And I think this is a nice way how you can, get it from this kind of high-level abstract level that Rankin is talking about to a more practical use case. Because, you can say that it's similar to permissions, but not in a way of rights, but in regards to what can be executed or accessed. And this is what capability is about, and I think in mobile development, you get the loop back to the practical program.
Example is Docker. You use something called capabilities. Because if one was spoiled, you don't use Docker.
Okay. Good.
So I'm going to be a bit faster now. So as I said, capabilities are not new. Just so happen you have it in the kernel of Linux since 1999, when there version 2. And you use two functions for what one is called setcap, we over a getcap. Getcap is the capabilities of this process, and setcap give you some extra permission. Here's the thing. Most people think that when you're root on Linux, you are God. No. Capabilities. They give you a way to bypass things you wouldn't believe. With capabilities, you need root capabilities, but you get the gist of it. You can even change your MAC address on your machine. So if some of you want to be a hacker, spoofing MAC address, how important it is. If you don't know how to spoof your MAC address, don't even try to be a hacker. Don't even try. Because you might spoof your IP, but if you can't spoof your MAC address, they're going to get you. It's not a good place. So, most system admin, not the beginner, intermediate, high level system admin, they know about capabilities. And guess what? capabilities, it's not only for system admin. Most do CI/CD and do the agile, whatever approach. The Docker. And most of you when you go in the stream say, oh, I do Docker. I have a CI/CD. And yet, those who talk about Docker, they have very few security on the Docker image because they don't know how to set capabilities and reset capabilities and drop capabilities. I'll show you how good it is. I didn't even try